What is number system? It's nothing but the language of numbers. And if you look at each language has got its own set of symbols. There are different kinds of number systems. Decimal number system, binary, octal, hexadecimal. And each language has got its own radix or base. This radix is nothing but the number of symbols in that particular language. Let's look at examples. Decimal number system. We human beings are familiar with decimal number system. 0 to 9. So there are 10 symbols. Obviously radix is 10. Here 1, 2, 4, 9, 5 is a decimal number. Binary number system. We engineers must be familiar with binary number system because we design digital systems. 0 and 1, only 2 symbols. Obviously radix is 2. Here is an example. Everything will be defined in terms of ones and zeros. An octal number system, there are 8 symbols, so radix is 8. Here 0 to 7, only 8 symbols. 7, 1, 2, 4, 5 is the octal number. An hexadecimal number system, there are 16 symbols. Here, if you look at it, it starts from 0 and after 9, it starts from A and it goes like this, B, C, D, E, F. There are 16 symbols. Here is an example, 9, A, B, D, 5. This is how we define different number systems. Okay. We have seen different examples for different number systems. But still you have this big question in your mind, what actually I'm going to do with all these number systems? It makes my life complex. No, actually it is not. In industry, as part of your project life cycle, you would be doing different things like simulation, synthesis, etc. Look at here. Let's say you are debugging simulation failure as a verification engineer. You are looking at the waveform. Here, all the values, input values and output values are huge numbers. So you don't want to look at everything in terms of binary because it's going to be very huge. So instead of looking at all the values in binary, you can look at those values in hexadecimal or octal. It would be easy for you to interpret the values. It would be easy for you to compare the values, output values with expected values, and then you can find out whether the waveform is clean or not. Okay. As a design engineer, you are writing the source code, Verilog program. While writing source code, you can define all the values in hexadecimal or octal. You don't really need to define everything in binary. During synthesis, actually the synthesizer is going to convert all the values that you have defined into binary, and then eventually it's going to generate gates, the circuit from your source code. It knows how to do that. So you don't really need to deal with only binary. And if the values are going to be huge, then you would be able to still define all these values easily in hexadecimal or octal. Or for example, an architect wants to define the specification itself. He has to explain how the design works, the functionality. And he may want to explain the possible input values and possible output values. If you are going to supply some set of values and these are all the possible output values, in that case, he doesn't have to define everything in terms of binary. Especially if the functionality is going to be complex, then he can choose different number systems like hexadecimal or octal. So if you look at the specification, the whole functionality of the design would be explained in terms of hexadecimal or octal. So what is really needed is you have to understand how to convert one number system into another number system, like hexa to binary or octal back to binary or hexa to decimal. All these things are really needed. If you don't know how to convert the number system, then eventually you won't be able to deal with the circuit design. For example, you start with the specification, everything has been defined in hexadecimal. And when it comes to the circuit design, you have to convert everything into binary because you can define the truth table only in binary. That's what we are going to discuss in this module. Thanks for watching this video. Thank you.